So with this logarithmic equation, let's try to get the logarithm by itself first. We'll add that 4 to both sides. So that makes it disappear on the left, and negative 7 plus 4 gives us a negative 3 on the right. Let's get rid of the negative sign. We'll divide both sides by negative 1, or you can think of it as multiplying both sides by negative 1. And now here is where there's a couple of different ways of thinking of this. You can think of taking each side and raising it on top of a power of e. That's, I guess, usually how it's explained. And the reason why we're going with e is because a natural log is a logarithm of base e. So e to the power of natural log, they're inverses of one another. They undo each other. So that means this simplifies to be this. And now we have a much simpler equation to solve. Now it's linear, right? Just got to add that 8 to both sides. Sorry, that would be my dog. And then divide both sides by negative 8. So, I'll check to make sure Newton accepts this way of typing it in, but divide both sides by negative 8. So this would be your solution. So you got e to the x and e to the negative x. So they're not. I think this one's going to be kind of challenging. You get them, and they're not like terms. You can't combine them. Look, 32 e to the negative x is the same thing as 32 over e to the x, right? A negative exponent means you can rewrite it by putting it in the denominator or vice versa to change the sign. So I'm thinking of multiplying everything by e to the x. And if you do that, e to the x times itself, that makes e to the x squared. And e to the x times e to the negative x, the powers would add to make e to the 0, so that's just 32. And then e to the x times 12 makes 12 e to the x. So this is quadratic in terms of e to the x. You could make a little substitution. You could say u is e to the x, because we've got a squared term. We've got a term to the first power, and then we've got a term that doesn't have e to the x. So u squared plus 32 equals 12u. And so solve that like a quadratic, set it equal to 0. And here's where you could use the quadratic formula or factor. I prefer to factor if I can. My hunch is that it is factorable. I don't know. No, what was I thinking? 4? That's it. Negative 4, negative 8. It is factorable. You can do u minus 4 and u minus 8. Because that's two numbers that multiply to be positive 32 but add up to be negative 12. And so if you solve each of those, you get u equals 4 and u equals 8. Now that's what u equals. We want to know what x equals though, so let's put e to the x back in for u. And to solve this equation, you got to get x by itself, so you're just taking a natural log of both sides. And you can simplify the logarithms a little bit. Look, that's 2 to the second power, right? So using your properties of logarithms, the exponent can come out. And this is 2 to the third power, so that 3 exponent can come out. I don't know how Newton's going to prefer it. I'm going to go check to see. I think it would be okay with either way. Newton wanted this format. You probably could type this in and mark it right, because it's got some sort of calculator in there to see if it's numerically equivalent or something. So last one of this type, trying to get x by itself. So let's get the exponent piece by itself first. I'm going to add 3 to both sides of the equal sign. So I'm trying to get x by itself. I'm going to try to get the exponent by itself first. So I'm going to get rid of this 5 by dividing 5 from both sides. And I think I saw that it wants fractions in its answer. And now I'm trying to get the x by itself. It's in the exponent. The trick we have up our sleeve is to use a logarithm. And natural log I like to write just because it's one less letter. You could use common log, whatever log you want. And I have to keep the equation balanced by doing it to both sides. So I'm taking a natural log of both sides of the equation. And the reason we do that is because of the exponent property of logarithm. The exponent property of logarithms. It says that this negative 4x plus 3 can come down and multiply to the outside of the logarithm. So the exponent comes down. Okay, trying to get x by itself. So let's divide this natural log 6 from both sides to get rid of it on the left. So you get negative 4x plus 3 equals... now when you're dividing two logarithms that have the same base... wait a second, never mind. No, okay, we just got to leave it like that. Kind of yucky. Natural log 14 over 5. Natural log 6. Even though I've taught it a million times, I keep confusing this rule if you're wondering what I was hesitating about. If you have x divided by y, that's natural log x minus natural log y, which is different than what this is, right? This is a logarithm divided by another logarithm. Okay, then we got to, now it's just quick algebra. Subtract 3 from both sides, divide both sides by negative 4. So x is going to be this crazy fraction. Subtracted by 3, and then everything is being divided by negative 4. So if you type that in, Newton should be okay with that.